Hello, we are back. So, to start off our second lot of talks, we have Luke from Discord. Discord.
Now, yeah.
Yes. Sorry, I'm still jet lagged, very jet lagged. So Luke is going to talk to us about QUIC and media over QUIC, and be very contentious about his hate of WebRTC. So over to you, Luke.
Yeah, sure. So, hello. Ali got the pleasure of starting ahead of me a little bit, but I'm going to focus a little bit on something else. We have a different style. He likes to focus a bit more on Dash. I'm here to nag on WebRTC. I'm here to be, the enemy in the room, as they said. So yeah, I'm Luke. I was at Twitch for like 7 years, but now at Discord when I worked on media over QUIC. Mainly to try to address the issues with HLS and getting lower latency. Went down the WebRTC rabbit hole of using it there, and then kind of came out the other end with an IETF working group to make something better. So I am doing WebRTC at my day job, but trying to get rid of it, actively. So I need help. That's why I'm here. Please let me out. This is all open source. Everything I'm talking about. QUIC.video. If you haven't seen it, it looks identical to these slides. You'll never imagine that I designed the website just by drawing, with a stylus. And these are my own opinions. These aren't for Discord or Twitch or whatever. This is actually something that I mostly worked on between jobs, just because I care about it a lot, and wish I had more time to work on it. So before I bore you too much, I'll just summarize the entire presentation. Get right to the point. So number one, WebRTC is gigantic. It's very difficult to replace, but there's also reasons to replace it. So it's a lot of work, but it's also a lot of benefit. There are new web standards that let us get there. A lot of the history is that you can't really replace WebRTC because that's required for web support. I mean, that's why you're using it at the end of the day. If you didn't want web support, you'd use RTP. You wouldn't go through the hoops. And then number three is time for a new media standard. Is it too early? Is this the time? What benefits do we get? And just talk about it a little bit. So first off, why WebRTC? This is a massive oversimplification. Don't at me. But effectively, it's like Google wants to ship Hangouts or Google Meet. And other conferencing solutions. But how do you do that in the browser? Back in 2011, we didn't even have HTML5. You didn't even have a video element that you could possibly use to render anything. The closest we had was Flash. So the idea is we could develop, or Google could, you could try and develop a lot more browser standards to do the low latency networking, the low latency capture and rendering, whatnot. Or you could take existing RTC standards, RTP, SIP, STP, all these existing standards, and then just kind of ship them as a sidecar in the browser. There is a JS API that lets you tweak some knob, turn some knobs, but really it's out of the control of the application. It's like you set it up, it runs, you get some metrics, but that's about it. And it kind of explains the philosophy in a bit of WebRTC is just get it out there, make it so it works. Don't make it too configurable, because at the end of the day, web was a different time. Why not WebRTC? This is for the technical audience, but who actually likes the protocols? I mean, other than Sean. STP is my classic yeah, I know I have to use it, I understand it, but it makes you die inside a little bit every so often. Or, every time you start to do ICE or turn or stun when you're just running a server. We're just hosting a server. Why do I have to go through 11 round trips to establish a connection? There are some good protocols. There are definitely some good protocols. I like a lot of them. Although, say, data channels, not my thing. Once you learn how they're made, they don't work very well. But that's not the point. We're not replacing a protocol just because we don't like the protocol. We're replacing it because there's business needs. And the main thing is, like, when you want to add something or you want to change something in WebRTC, you really have to go through libWebRTC. You can do some things on the server side, like you can run your own SFU to do some creative things. But if you need browser support, again, that's why we're using it, you got to make sure it works with libWebRTC. You got to make sure that Google wants it to work. And it's tough. Like, I've submitted patches, and they just, one-line changes to fix things, and they just go, unfixed. It's a monolith. It's huge. It's massive, right? And that's kind of to go back to the history lesson a little bit. It's everything all in one. Even making tiny changes, like just trying to build it. Everybody has probably tried to build WebRTC at some point, and it takes like maybe a month to set up your build system, just because it's so huge and tries to vendor everything and tries to do a lot. And it's a black box, effectively. Like, when you're not trying to fork it, you just sit on the outside and you pray that when you turn a knob, it will actually work. You pray that when you munge the SDP, that it will read it and obey it, for example. There are some knobs for sure, but it's really meant to do its own thing. And when it doesn't work, you're kind of like left scratching your head. And that's effectively a lot of the issues, I think, with WebRTC, is when you want to do something like slightly higher latency. It's hard. It's really hard. When you want to do, it'd be nice if there was like an escape valve. But when it does work, WebRTC is great, especially for conferencing. Like, it's designed for conferencing. It does a fantastic job at it. It's real-time latency, which is very hard, but it does a great job at getting real-time latency. Can't really go too much higher. I like to harp on the no B-frame support, because it adds like maybe 30 seconds of latency, 30 milliseconds of latency, but it's just not supported by WebRTC because it's not one of the things it's trying to solve. So it's really good at real time. I tried to use it for Twitch, trying to use it to present live streams, and I just couldn't, even with Pion and forking Pion many, many times, couldn't get the quality high enough that it was a better alternative than HLS. Limited scale, you can do things for sure, but a lot of it is the coupling of business logic and the transport together. So when you go to a CDN and you say, hey, you want to scale WebRTC, they have to know some media-specific things. They have to build it has to be a very conference-specific CDN. It's not a generic transport, is what I'm trying to say. It's not like HTTP, where the CDN doesn't really care what the body is in the payload. It's very much like, this needs to be H.264, you need to negotiate it as STP, I need to know what the content is and to know what to deliver. And it's very one-off as well. That's also why I would say the main scaling issue with WebRTC, it's for conferencing. It doesn't really have too many applications outside of that. And P2P is really cool. I will say, coolest part about WebRTC is that you could do peer-to-peer in the browser. It's not too useful though, at least for bigger companies. It's the quality you can get is not great. I mean, that's just how the internet works. Why you have CDNs in the first place is P2P is nice, but you jump through a lot of hoops in WebRTC just for peer-to-peer support, even if you're not planning on using it. And yeah. But it does work. Again, as I mentioned, it's a great user experience. There's a lot of really smart protocols in there. I just mentioned a few of my favorite, like transport-wide CC, GCC, retransmissions, FEC, PLIs, SVC, RED, whatever. There's a lot of really cool stuff. The Google engineers are really smart. Like, it is a very well-made protocol. It does probably the minimum latency you could get on the internet, as far as I know. There's a few more techniques maybe you could do, but it's pretty good. And you can tell based on when you look at the code base, there's a lot of origin trials in there. There's a lot of testing that goes on, and you get that for free by using WebRTC. You get the extensive testing in production to get these low latencies. So WebRTC is not going anywhere. I'm not here to say you guys, like stop working on it. It's just know that it is a rather limiting box. And I'm here to say what's next, what alternatives exist, what might be here in the future. End of the day, like I said, we're limited based on web support. If you want to do real-time conferencing, on the web, you got Flash. which does not a thing anymore. WebSockets, HTTP, and that's about it. And when it comes to encoding and decoding, there's not much you can do. There's some basic things. But we got 2 new web standards that are in Chrome. Firefox has WebTransport and was working on WebCodecs, and Safari is the other way around. They have WebCodecs and working on WebTransport. So not full support yet. It's coming in the next maybe year or so, I would say. There's some bugs in both, but that's what you get by being on the bleeding edge. WebCodecs, I think, is really cool because it's really simple. You have an encoder. You effectively just say, hey, here's a frame. Here's a canvas, or here's a get display media from WebRTC. Here it is. Please render it. Not please render it, please encode it, and it just spits out a bit stream. Just gives you the encoded H.264, H.265, whatever, AV1. And then on the other side, you can just give it a bit stream. Just give it a raw codec, and it will give you frame objects. It'll give you a video frame. And then you call draw 2D image to actually draw it. You choose when to render. So it is just a video encoder and decoder in the browser. Really simple. The gotcha is that you have to do everything yourself, especially with audio. There's none of this like, oh yeah, just like please render it for me, like render to the screen. You get full control to, you have to put like sleeps effectively in your code, like set interval or set timeout to wake me up in 5 milliseconds to draw the next frame, which is good in some senses, because now you can do frame dropping, you can do frame skipping, you can do a lot of the advanced stuff that WebRTC does to get low latency. Unfortunately, you need to do it yourself or have a library do it, but it's in JavaScript. JavaScript is responsible for actually choosing when to render things. Audio is the main call out here because audio is hard, and you get a lot of stuff for free from WebRTC, like I would say noise suppression, echo cancellation, gain control, any filters, whatever. You could do it. You just have to do it with all WebCodecs. You have to do it in JavaScript. You render individual audio samples, and if you want to change the volume, for example, you have to amplify those audio samples. It gives you full control. But it wouldn't help if you just had WebCodecs by yourself. You can use it. I think there's a feature like insertable streams or some world you can use it with WebRTC 2 to just render or encode however you want. But there's another way as well. If you just want to use WebRTC for networking, there's a new kid on the block. WebTransport. You can think of it kind of like data channels, but like better. Or think of it like WebSocket, but better. There's a few different ways of thinking about it. But it's quick. It's quick in the browser, one-to-one. You have either streams, which are, think of them like TCP streams, but they're independent of each other on the same connection, or even datagrams. You can actually send individual MTU-sized packets within the browser now. There's a gotcha. That's why I had to put the asterisk there. It's not UDP. It will never be UDP, because browsers don't want applications sending a raw fire hose of packets. Nobody wants that. So there are some gotchas. So like I said, there's a few different techniques. We want to get latency as low as WebRTC. We're only going to use these tools if they give us that latency we need. I'm not going to, WebSockets, for example, is head-of-line blocking. Not really good enough for latency. How do we avoid that head-of-line blocking? That's the main reason why WebRTC uses UDP in the first place, is that you can avoid waiting for old data. You can skip it. You can drop it. So there's a few ways of doing that. With streams, you can abuse the fact that each stream is independent. You can prioritize them, and you can reset them when you're done, when you just want to drop it. And you just reset it with an error code. So you can, for example, the old group of pictures or the old audio frame, you can deprioritize it, and then eventually either side can say, no, it's done. So that's something way more than TCP can ever let you do. And then there's also the other option is datagrams. You can send RTP over WebTransport, which is what I did actually for a little bit. I did RTP over WebTransport. But I realized I was just re-implementing QUIC in a lot of cases, so I just got rid of it at some point, but you can totally do it. It's like UDP, but it is congestion controlled, is a big takeaway. You cannot send it unlimited bit rates. QUIC under the hood will limit your bit rate to whatever it decides is a safe limit. So it does limit what you can do. You can't do GCC, for example, with datagrams. So scratching it out, I tried it. I'm just telling you guys, like, it is probably the easiest way to get things going is you can take an existing RTP stack and just instead of UDP, you just use WebTransport as a UDP replacement. There's just a few gotchas. So I'm focusing on the stream side. And I want to quickly show how it works, just the concept. This is what you've been waiting for. This is how we are able to replace WebRTC and still get low latency. Is we can take the media bitstream. Let's say we're falling behind a little bit because there's some congestion. We've got some video, a bunch of P frames, and then a new iframe and some Ps. And then audio are just individual audio samples. So in an ideal world, what we deliver depends on the latency we want. So if we want a high latency, we're willing to wait longer for some of this old data. And if we want real time, we want to just drop the old data immediately and just don't wait for it. So the way that you do this with RTP is you effectively take the video and you chunk it into individual packets. You packetize it into 1.2 kilobytes. You can do higher or lower, but MTUs are annoying. Unfortunately, you have to depacketize it, and this is why WebRTC is hard to scale a lot of times. It's hard to know what is in a packet. Is it important? Should I drop it? But you choose. You eventually decide, these ones, too old. I'm not going to retransmit them. You flush the queue a little bit. You drain it, and you make sure you only you spend your bandwidth, your limited bandwidth, because there's congestion on the important data, the most important video. Hopefully the iframe. It's hard to tell. That's one of the issues. And worst case, you send a PLI to make a new iframe, right? With QUIC, it's a little different. With Media over QUIC, the idea is you effectively take your either entire frame or the entire GOP and put them over an ordered stream. So in this example, we have the old GOP, the P frames are in a stream that was going on for a while. And we make a new stream for the new group of pictures that's coming. And we're just making a stream for each audio frame in this example, which you could do. And we give them priorities. We tell the QUIC stack, hey, all things else, send the lowest number first. So if it has to decide if it sends packets for what the next packet's going to send, it's going to send the newest audio first. It's not going to send the old video. And both sides can also reset the streams. That's another way of doing it. There's two kind of approaches that work in tandem. The other approach I also put here with the red X is you can just reset. You can see that you've gotten 200 milliseconds of the new video GOP, and you can just say, stop delivering the old one. Or the sender can do that too. So a lot of different approaches. Really, end of the day, you need to decide what media is most important, and you need to use your limited network on that media first. And you can do it by dropping packets, or in this case, dropping frames, or dropping GOPs, or by prioritizing. So a lot of tools. There is a standard being worked on. You don't need to use the standard. Everything I said here does not rely on the standard. The standard is a little early, but it is a IETF working group. So it's the same, IETF is the same org that does HTTP, DNS, RTP, WebRTC. What are their favorites? Basically everything on the internet, every protocol on the internet. And there's a working group. It's an official working group. It's going to be a standard one day. It's probably going to take years, say 3 to 4 years or something, because there's a lot of design by committee and bickering. But Google's heading it with Meta. Cisco has their own version of Media over QUIC. They published, and a few of them are working on it. I'm the lone Discord representative, and originally Twitch, but I'm the original author, which is cool, so my name's on it. Google's taken it over basically now, though. Akamai, Will's super into this project. Cloudflare, I put it there, but it's a few people here and there getting involved in Fastly, same things, a lot of behind the scenes, because QUIC is great, and it'd be nice if you could use QUIC as well to deliver media, not just HTTP. And QUIC goals, why the standard exists in the first place, is really just to take the CDN component of Media over QUIC and make it generic, such that then it doesn't even have to know about media as a concept, and just design the protocol with mass fan out in mind and any latency. So it is really designed for CDNs. This current mock transport that Ali talked about, it doesn't mention the word media, even though it's in the Media over QUIC. It's generic, so the actual payloads could be chat, DRM, end-to-end encrypted, whatever. Best way of thinking about it is think about like HTTP headers will tell the CDN what to do. and the payload is whatever you want. You know, it doesn't matter. You don't need to make it work with a depacketizer or something like that. And any latency. Focusing on making sure that it is a WebRTC competitor. It could do real-time latency. It's hard. Even the other end, where to VOD or to DVR. And of course, that sweet spot, which is like around the 500 milliseconds to 1 second mark that no protocol currently can serve. And that was Twitch's main issue, actually. It was just there's a gap there. There's more. This is basically my blog. Quick up video. There's some demos. I want more time to work on it. I'm working on a conferencing demo, for example, just to show, yeah, you can do two-way conferencing, not just my contribution or distribution demos separately. A lot of resources on there. There's a big Discord now, and talk to me. Just whatever, if you're interested or want to learn more. And that's all I got.